Today we will discuss about C++ basic data types. I have written few of the data types over here. Let us have a look at that. Character data type occupies 1 byte and the range of values it can store is -128 to 127. Integer, it takes 2 byte and the range of value is -32,768, 32,767 is the positive number. So you can see this small table which I have written. Few of the data types has been written, and if you can observe here, each of this magnitude of the data type, there is a particular variation. What is that? Each data type can store one number extra when it is negative. And for example, if you take basically an unsigned character, it can store minimum 0 and 255 as the largest value. And signed character, it is storing -128 to 127. Now you may be wondering why exactly or how exactly one negative number is stored extra. So to understand this, let us go to the basics of computer a little. There are different methods in which a negative number is stored in the computer. One of the methods is sign and magnitude method. In this method, the most significant bit of a byte, 0, most significant bit is used for representing the number, whether it is a positive or a negative number. So it is actually called as a sign bit. Suppose I want to represent positive number 1 in binary, I would write like this. If I am writing a negative number, I would represent the same value with most significant bit having 1 as the bit. 0, 1, 2, 3, 4, 5, 6, 7. So, if I write like this, it means I am representing -1. Here I am representing positive 1. Let us now take up a smaller example. Suppose I want to store a number using 2-bit space. In that case, the numbers which I can store in 2-bit space could be 00, 10, 01, 11. So you can see that when I have 2-bit space, I can store 4 numbers. That means 2 to the power of 2. 4 numbers can be stored. The lowest number is 0. Highest number is 3 in the binary form. Similarly, if you have 4-bit space, then you can store the first lowest number will be 0. Then you can store what? 001. Like this you can have varied. So what is happening? This is 2, this is 3, like this it continues. And with the 4-bit, you can represent the number. The largest number you can represent is 50. So 2 to the power of 4, you can have 8 combination. 8 numbers can be represented, and the lowest value you can store is 0. Highest is 50. So what you are observing over here is, when you have 2-bit space, the largest number you could store is 3 and the smallest number is 0. 0 to 3. So totally 4 numbers you could store in 2-bit space. Similarly, with the 4-bit space, you can store how many numbers? 0 to 15. 16 numbers can be stored. To the power of 4, that is 8. And to the power of 4 is 16. So similarly, if you have 8 bits, 2 to the power of 8. So here, since the most significant bit is used as a sign bit, so it is going to be 2 to the power of 7. So 2 to the power of 7, it is working out to be as 128 numbers you can store. The lowest number you can store is 0, highest is 127. So you can see that lowest is 0 and 127. That too what? Positive. 0 to 127. So the lowest negative value which you can store is basically negative value. What is the range? You can store -1, -2, -3 and so on. The largest or the lowest negative value will be which could be represented using 7-bit. Would be that it is to the power of basically 7, but one largest, that is the most significant bit, can also be used to represent one more negative number, and that would be -128. So what you understand over here is, to wrap up, we are going to use the most significant bit for representing the sign of a number, and the rest of the bits are used for representing the magnitude of the number. When in case of negative numbers, the most significant bit, the sign bit, can be used to represent the magnitude of the lowest number of the negative value. So that will be -128. So that is the reason why you can represent the negative number as -128 and positive number as 127. So the magnitude is actually going to be represented with the 7-bit, and the sign bit is used to represent positive and negative number. But in case of negative number, the sign bit is used extra to represent one extra value, that is -128 in case of characters, whereas in case of integers, one extra value it can represent is -32,768 and so on. So what you could see that is the variation. You can see that negative numbers, you have one extra value represented in case of characters, integer, and in any of the data types further what you are going to